Okay, Bismillahirrahmanirrahim. Assalamualaikum and hello everyone. So in this video, I will continue untuk sambung lecture daripada Madam Afina, which is chapter 3.2 Binomial Expansion. Okay, so what I want you to do is please listen carefully and please complete your lecture notes lah. Okay, jangan dengar saja-saja, jangan dengar suka-suka. This is not a movie, so please complete your lecture notes. Okay, so in this video, saya akan sambung dengan Binomial Theorem 1. Okay, so this is the formula you're going to use. So bila kita akan pakai theorem ni ataupun formula ni, it is when we have a plus b to the power of n, and also our power must be a positive integer. I repeat, it must be a positive integer. Meaning, awak tahu kan integer tu apa? Kita dah belajar dekat chapter 1 hari tu. So integer is basically number including the negative, negative 5, negative 4, negative 7, 0, 1, 20 and so on. But in this case, dia kata it must be a positive integer. So meaning, your n gonna be 1, 2, 3, 4, 5 and so on. Okay, so this is the only n which is acceptable to use this formula. So besides that, if your n is a negative number or your n is a fraction or other than that, you are not going to use this formula. Okay, tak boleh pakai formula ni. Okay, alright, so let's see the formula sekali lalu. Okay, so the formula is we have a plus b to the power of n. So kita akan expand dia using binomial theorem, which is we're going to have n choose 0, and then yang bawah tu akan increase 1 by 1, become n choose 1, n choose 2 until n choose n. Okay, and then untuk coefficient a pula, for the a, we're going to start with a to the power of n, and then the power going to decrease 1 by 1, become a n minus 1, a n minus 2, until we get a to the power of 0. And then for our b pula, so b kita akan start dengan balik, dia akan start dengan power 0 pula, and then the power going to increase 1 by 1, so become b1, b2, b3, until we get b to the power of n. Okay, so for the first time, maybe the formula going to seem quite confusing to you, so kita akan start dengan example. Okay, kita akan try dua example for you to see how it works. Okay, so let's say we have this one. Okay, 2 plus x to the power of 5. So dia kata by using binomial expansion, which is this one, expand the following. Okay, so we need to check our n. Yes, it is a positive integer, so we have no problem with that. And we have 2 plus x, so we have a plus b. Okay, so saya keluarkan info yang ada. So our a in this case is 2, our b is x, and our n is 5. Okay, this is the info that we have. So now we're going to expand using the formula. So based on formula, 2 plus x to the power of 5 is equal to n choose 0. So 5 choose 0, 5, 0. And then our a to the power of n. So our a is 2 to 2 to the power of n. N in this case is 5. And then b to the power of 0. So x to the power of 0. Okay, this is the first expansion. So we're going to continue until the end. So the next one is 5, choose 1, the n going to increase by 1, and then 2, 4, x, 1. Okay, so our power for the a going to decrease, and our power for the b going to increase. Okay, we keep going. So next 5 choose 2 pula. Okay, dia akan increase, yang bawah ni akan increase 1 by 1. So our a to the power of 3, our x to the power of 2. Okay, and continue lagi. So we have 5, 3 pula. 5, choose 3, and then kita punya a decrease the power, our b increase the power. Okay, belum habis lagi, we continue until we get 5 ataupun 5 choose 5. Okay, so next one, 5 choose 4. So our a is 2, the power gonna decrease, and then our b, the power gonna increase. Okay, and then last one, 5 choose 5. So our a gonna become 0, and then our b gonna become n. So our b gonna become 5. Okay, baru settle expansion kita. Okay, so kita check dulu. So kita akan start dengan 0, 1, 2, 3, 4, 5. So yes, we're gonna end with 5, 5, which is n choose n. And then the power of a, so this is our a, the power gonna decrease 1 by 1. So 5, 4, 3, 2, 1, 0. Okay, nice one. And then for the b, the power gonna increase 1 by 1 until we get n. So x power 0, 1, 2, 3, 4, 5. Complete. Okay, So belum siap lagi. Now we need to calculate the value yang kita boleh calculate. So for this one, the first expansion, we have x to the power of 0. So anything to the power of 0 is 1. So 1 multiply with this, you just need to press your calculator. 5, choose 0, multiply with 2 to the power of 5. You're going to get 32. 32. Okay, plus, expand this one. Sorry, you calculate this one using your calculator. You're going to get 80. So 80. And then you have x over here. So x to the power of 1 is x. Okay, next one, we have this one. So we have x2. And then this one, you just need to press your calculator. You're going to get 80 also. So 88 square. Continue. The next one, you're going to get 40 x to the power of 3. And the next one, 10 x to the power of 4. And the last one, x to the power of 5. Okay, so I have 1, 2, 3, 4, 5, 6. So I have 1, 2, 3, 4, 5, 6. Okay, so this is your final answer. Okay, this is your final answer. Alright, so now let's try another one. Okay, so to make sure you really understand on how to apply the formula. So the second example, we have 1 minus 2x to the power of 4. So check your n. Your n is positive integer, so we can use this formula. We have a plus b. We have 1 plus negative 2x. Okay, so we can use this formula. So I extract the info that we have. So in this case, our a is 1, and then our b is negative 2x. Why? Because based on formula, we have plus b. So we have plus negative 2x over here. So you have to include the negative, okay, for our b. And then for our n, we have n equal to 4. Okay, so now we have the information we needed. We can apply the expansion. We're going to apply the formula for the binomial expansion. Okay, so we have 1 minus 2x to the power of 4. Okay, we're going to get n choose 0, so our n is 4. 4 choose 0. So our a is 1. So 1 to the power of n. Our n is 4. And then our b is negative 2x to the power of 0 plus 4 choose 1. Okay, the number increase 1. And then our a, the power gonna decrease. And our b, the power gonna increase. Okay, and then we continue. We have 4 choose 2. Our a gonna decrease in power. Our b gonna increase. Okay, and then we continue. We have plus 4 choose 3. 1 to the power of 1. And then negative 2x to the power of 3. And then last one, we have 4 choose 4. Okay, the last term, 4 choose 4. And then our a is 1 to the power of n minus n, which is 0. And then our b, power of 4. Okay, so just in case, let's together check. So we have 4 choose 0, and then choose 1, choose 2, choose 3, choose 4. And for our a, we have the power of n, and then the power gonna decrease one by 1. 4, 3, 2, 1, 0. And then for our b, the power gonna increase 1 by 1. So 0, 1, 2, 3, 4. Okay. So now we just need to calculate the value. So for this one, anything to the power of 0 is 1. So we just need to press calculator for this one, and you get 1. Okay, and then for this one, we have negative 2x. So we have x over here. So you just need to calculate this one, including the negative 2. So you press your calculator, you're going to get negative 8. Negative 8. And since we have x over here, we just need to write the x. Okay, plus. Okay, so we have negative 2 to the power of 2 is 4. Okay, 4. We have 4x squared for this one. So we need to multiply this one along with the 4. So we get plus 24x squared. Okay, and then for this one, the 3 is belong to negative 2 and x. So it will become negative 8x to the power of 3. So we multiply this one. Press this one into our calculator. We're going to get negative 32. Negative 32. And then x cubed. Okay. And then last one, for the last one, we have this one. So this one is 16. Is it 16? 2, 4, 8, 6. Yes, 16 to the power 16. X to the power of 4 for this one. And then you multiply with the ones in front. You're going to get 1. So it's going to become 16x to the power of 4. Okay, so let's just check. So we have 1, 2, 3, 4, 5. 5 term. And the final answer have 1, 2, 3, 4, 5 term. Okay, so correct. So this is your final answer. Okay. Oops. Alright. So that's how you use the binomial theorem to expand your expression. Okay. Okay guys, so now let's continue with the second formula for today. Okay, so just now you has already learned how to apply the binomial expansion theorem, which you need to expand the expression one by one, right? Okay, so let's say the question asks you to find the specific term. Okay, for example, we have this question. Okay, we have already expanded, so the question asks you to find only the fifth term. Okay, only the fifth term. So this is quite easy because you can see that this is your T1, T2, T3, T4, T5. So this is your T5. Okay, this is quite easy because you just need to expand a very short one. But how about if you have A plus B to the power of 100, let's say, or maybe, for example, 1 plus X to the power of 100, and then the question asks you to find the 98th term. Okay, so this is going to be a very long working, right? So you're going to spend a whole day to expand it. So there's no need to expand one by one to find the 98 terms. Instead, you're just going to need to use this formula. Okay, so the formula is we have T R plus 1 term going to equal to N choose R, A to the power of N minus R, and B to the power of R. Okay, to see it more clearly, we're going to straight to the example. Okay, so for the example, we have A plus B to the power of 8, and the question asks you to find the third and sixth term, which is the T3 and T6. Okay, so you don't need to expand one by one because they just need you to find two term only. So we're going to use this formula. So how? Okay, so this is how you do it. So for the T3, the third term, okay, so we have T3. So to apply this formula, you need to have TR plus 1. So T3 is actually equal to T2 plus 1. Okay, why 2 plus 1? Because we want to make sure it is the same as the formula. Okay, T3 is equal to T2 plus 1. So for this case, your R gonna be 2. Okay, take note of there, your R gonna be 2. Okay, so once you already know your R, you can straight using the formula, which is T3 equal to T2 plus 1 is equal to, this is the formula, so N choose R. In this case, you have N equal to 8. Okay, this is your N, and this is your A, this is your B. So N choose R, so 8 choose 2. And then A to the power of N minus R, N minus R. So 8 minus 2, and then B to the power of R, B to the power of R. Our R is 2, so B to the power of 2. Sorry. Okay, so we get 8 to the power of 2. Sorry, 8 choose 2. You can just press your calculator. You're going to get 28 if I'm not mistaken. And then A to the power of 6 and B to the power of 2. Okay, settle. So this is your third term. Okay, this is your third term. Now let's try our sixth term. Okay, sixth term. So it's the same step. So we want T6. So based on the formula, we're going to have TR plus 1. So you're going to rewrite it as, T5 plus 1. So you're going to get your R is 5. Okay, your R is 5. Okay, so now let's use the formula. To T6 equal to T5 plus 1 is equal to N choose R. So 8 choose 5. And then A to the power of N minus R. And then B to the power of R. Okay, so press calculator for this one. You're going to get 56. And then A to the power of 3, B to the power of 5. Okay, settle. So your third term is this one, and your sixth term is this one. Okay, so now let's continue with second example. So this example is quite different from the previous one because they want you to find the coefficient of y to the power of 5 and x to the power of 6 of this one. Okay, so first of all, make sure you write your info first. So you have A equal to x, your B equal to y, and your n equal to 9. Okay, this is the info that you got from here. So you want to find which term that consists this one and this one. Okay, so we're gonna use this formula. So how do we use it? So what we know, we want to find the term that has y to the power of 5, right? So we don't know which term. So first, I just need to write the formula first. And choose r. So a n minus r and b to the power of r. Okay, so I just insert the info that I know, which is we know the a, b, and n, right? So I just put it into our formula. So our n is 9. R we don't know yet. Okay, so just put r. And then our a is x to the power of 9 minus r, and b is y to the power of r. Okay, alright, so now we can compare. How do we compare it? We have y to the power of r over here, and we want y to the power of 5 in our term. Okay, so we just need to compare. So yr gonna need to become y to the power of 5. So we have r is actually equal to 5. Okay, so we know that when r is equal to 5, we're gonna get the y to the power of 5 as in our term. Okay, so this is not your final answer yet because they want the coefficient of y to the power of 5. So coefficient is any unknown or any number that is multiplied with the y to the power of 5, which is this one. Okay, so I just need to insert back into our formula. So we now know our r. So our t, 5 plus 1, or t6 is equal to 9 choose 5. And then x, 9 minus 5, and y power 5. So 9 choose 5 is 1 to 6. And then we have x to the power of 4, y to the power of 5. Okay, so the coefficients of y5 is any number or any variable that is multiplied to the y5, which is this one. Okay, so this is your answer. Okay, this is your final answer. Okay, this is your coefficient. Okay, so we try another one, the same one, but for this case we want to find term that has x to the power of 6. Okay, so we just need to use the same method. Okay, so you just insert your formula first. So we have 9 choose r, x 9 minus r, and y power of r. Okay, we don't know the r yet because we don't know which term that has x to the power of 6. So now we can compare. Okay, so we can compare this one with this one. Okay, since we need to have x to the power of 6, so we need to make it equal to x to the power of 9 minus r because this is the only x that we have. Okay, so we need to compare this one. So we have 6 equal to 9 minus r. So r is equal to 9 minus 6. 9 minus 6, so r is equal to 3. You get r is equal to 3. So again, this is not your final answer yet because they want the coefficient. Any number or any variable that is multiplied to the x to the power of 6. Okay, so just insert into your formula. So you have t3 plus 1. t3 plus 1. So we have t4, or the fourth term, is equal to 9 choose 3, x to the power of 9 minus 3, and y to the power of 3. Okay, so 9 choose 3 is 84. You can just press your calculator. So x to the power of 6, y to the power of 3. And then we can rearrange it. So we have x 84, 9 to the power of 3, x to the power of 6. So what is your coefficient? Coefficient of x to the power of 6 is 84, y to the power of 3. Okay, that is your final answer. Okay, this is your final answer. Coefficient is any number or any variable that is multiplied to the x6. Okay? Okay, so this is our last example for today. So you need to determine the terms independent of x. So what does it mean? You have to find term that doesn't has x. Okay, in your term. Okay, you have to find it. So how do we do it? First, of course, you need to extract info first. So you have a equal to x, your b is 1 of x, and your n is equal to 8. Okay, so we're still going to use this formula, the term formula, because we need to find the specific term that doesn't has x. Okay, so you don't waste your time expanding one by one. Instead, we can just use this formula. Okay, so how do we want to make sure that our term is independent of x? Okay, so we can simply make sure that our x is to the power of 0. Okay, we just need to find the term that has x to the power of 0. Why? Because x to the power of 0 is equal to 1. So there is no more x in your term. Okay, so same as before. First of all, I just need to write my formula. Okay, you just need to write your formula. So we have a n minus r b to the power of r. So we insert the info that we know, which is we know our n, and we know our x, and then we know our b. Okay, so we can simplify it. We have x n minus r. Oh, sorry, we know the n, right? Sorry. So wait a minute. 8 minus r b power r. What do I do? 1 over x power r. So, and then this one, we can write it as x to the power of negative 1 to the power of r. Okay, so it will become x 8 minus r x power negative r. Okay, so we can simplify more because we have the same base for index over here. So the power gonna become plus. Okay, so 8 choose r. So 8 minus r plus negative r, so become negative r. So we get 8 choose r x to the power of x minus 2r. Okay, this is the simplest form that we can get. So now again we can compare the power. So we want x to the power of 0, so you just need to compare with this power to find our r. So 0, x to the power of 0 is equal to x to the power of 8 minus 2r. So 0 is equal to 8 minus 2r. So 2r is equal to 8, so our r is equal to 4. So we already get our r. Okay, now we insert back into our equations of term. So we have t r plus 1, so we have t 4 plus 1 or t 5. Okay, so our t 5 is 8 choose 5. So you don't need to use this formula, you just need to use the latest one. Okay, just insert your r into this. So we have x to the power of 8 minus 2 multiply with 4. So 8 choose 5 is 70 and x to the power of 0. So we have 70 as our final answer. Okay, because x to the power of 0 or anything to the power of 0 will always equal to 1. So yes, we found the term. We have found a term that is independent of x or doesn't have x. Okay, so this is your final answer. T5 is your answer. Okay. Alright, so you can try this one by your own. So the answer is T5 and is equal to 5670. Okay, thank you. That's all for today.